Priyanka. Today we are going to solve a problem on turning moment diagram and flywheel when extra torque is provided to the engine. In this video, we are going to understand how to draw the turning moment diagram with the help of calculation, and also we are going to use the basic simple formulas instead of using complicated formulas. Now first I will read what is the given problem. A certain machine requires a torque of 5000 plus 500 sin theta Newton meter to drive it, where theta is the angle of rotation of shaft measured from certain datum. The machine is directly coupled to an engine which produces a torque of 5000 plus 600 sin 2 theta Newton meter. The flywheel and the other rotating parts attached to the engine has a mass of 500 kg at a radius of gyration of 0.4 meter. If the mean speed is 150 rpm, find first fluctuation of energy, second the total percentage fluctuation of speed, third the maximum and minimum angular acceleration of the flywheel and the corresponding shaft position. So this was the given question. If we observe the question, it is given that torque T1 is required to drive the engine, and here T1 is equal to 5000 plus 500 sin theta, and torque T2 is provided to the engine. So here T2 is equal to 5000 plus 600 sin 2 theta. So these two are different torques. We can say that two torques meet at point when T2 minus T1 is equal to 0. So how to find out at which point these two torques are meeting? So if we draw here the turning moment diagram, so on this vertical line there is the torque in Newton meter. So we have to write here as a torque in Newton meter, or we can also say turning moment, and on this horizontal line there is the crank angle. Now I will take here the crank angle for one complete revolution, that is the angle of 360 degree. And we have to make here some parts. In case here I will make the partition for this 45 degree, that is 0 to 45, then 90, 135, 180, 225, 270, 315 and 360. And on this vertical line we have to plot the torque in Newton meter. Now at these different angles, what is the value of torque for this first equation as well as second equation that we have to plot? So if we calculate those value of torques, then we can easily draw the curve for these two equations. Now we can also find out the points at which these two torques meet. How to find out? When this T2 minus T1 is equal to 0, then if we calculate the angle theta, then at that angle theta these two torques meet at a point, or we can say the point of intersection of these two torques. So first I will take the equation, that is 5000 plus 600 sin 2 theta minus 5000 plus 500 sin theta. So if I take the minus sign inside, then this 5000 is getting cancelled, and what is the equation? 600 sin 2 theta minus 500 sin theta. So when we solve this, that is which is equal to 0, because we have to find out what is the point at which the two torques meet. So when I take this equation is equal to 0, then I will take here 600 sin 2 theta, I will shift this 500 sin theta to the right hand side, that is which is equal to 500 sin theta. So this sin 2 theta means what? 2 theta means sin 2 theta is equal to 2 into sin theta into cos theta. So this is the equation. Now I will divide on both sides with this 500. So if I divide, it will become 1.2 into, instead of sin theta I will take 2 into sin theta into cos theta, which is equal to sin theta. So now I have two options to solve this. So when I will take this sin theta is getting cancelled. That means I will take here sin theta is equal to 0. And when I take sin theta is equal to 0, I will get the angle theta is equal to 0, 180 degree and 360 degree. And now in this case, if I shift sin theta to the right hand side, then it will become sin theta by sin theta is equal to 1, and this cos theta is equal to 1 divided by 2.4, which is equal to 0.4167. So with the help of calculator we can calculate, and which is equal to 65.4, that is, this value is in the first quadrant. Now if we observe, this cos theta value is positive in the first quadrant. Now it is also getting repeated, and it is also positive in the fourth quadrant also. So how to find out this value? So this value in the first quadrant. So if I move from first, second, third and fourth. So here total angle is 360 degrees. So from this angle 360 degree I have to subtract this same angle, that is 65.4. So 360 minus 65.4, which is equal to 294.6 degree, is also the angle at which the two torques meet at this angle. So these angles are important. Now to plot the graph, I will find out what is the value of T1 and T2 at different angles. So for that, these two equations are important, that is the equation of T1 and equation of T2. So first I will take some angles here, and I will show you how to calculate. So if I take first is 0, so sin 0 is 0, so for T1 it will become 5000, and for T2 it will become 5000. Then here first I have plotted this T2 and then T1. Then for 45 degree, so for 45 degree if I plot here sine of 2 into 45, that is sine of 90. So I have to take sine of 90, that value multiplied by 600 plus 500. So here will be 5600. And if I will take here in case of T1 here sine of 45. So sine of 45 we have to take multiplied by 5000 plus 5 multiplied by 500 plus 5000. So here is 5353.5. So in this way we have to plot all the values. So for sine 90 we have to take here. So if I take angle theta is equal to 90, so in case of T2 I have to multiply with 2, because here is 2 theta. So 90 into 2, that is 180, that I have to take, and then we have to solve this. So in this case these are the values. So with these torque values I will plot here the points. So first we will plot the graph for T2. So how to plot? So first value at 0 degree T2 is 5000. So I will take here 5000. Then for 45 degree it is 5600. So above that 5600 value is there. So I will take here 5600. For 90 it is again 5000. So for 90 again it is again 5000. Then 135 it is 4400. So for 135 it is 4400. So here this is the value. Then 180 again it is 5000. So for 180 I have to plot here as a 5000. Then 225 5600. So 225 again I have to reach here 5600. Then 270 it is again 5000. So 270 I have to reach here as a 5000. 315 4400. So here is 4400, and 360 again 5000. So these are the points. So for this 45 degree it is 5600. So I will remove this. So these are the points. Now I have to join these points. So I will draw this curve with the help of the black marker. Now again we will move for T1. So these values of T1 are already getting calculated. So here is 5000. So I will draw here with help of red marker. 45 degree 53.5. So here is the point. So I will join. Then 5500. So for 90 again 5500. So again I will join this with smooth curve. Then 53.5. So again here 53.5. Then again 5000. So for 180 it is 5000. Then 225 4646.4. So for 225 here 4646.4. Then again 4500. For 270 it is 4500. So I have to join this. Then again 4646.4. For 315 again 4646.4, and again it is 5000. Now if we observe, these are the two graphs. Here the curve with this black marker is for torque T2 and curve with this red marker is for torque T1. Now I will give here some letters or notations for the point of intersection for these two curves. So here first point will be point A, then here is also the point of intersection, that is point B. Then again if we observe, here is the point of intersection, that is point C. Then here is point D and here is point E. Now we have already calculated the angle theta for which the point of intersection between the two torques T1 and T2. So first angle is angle 0. Then again we have calculated the second angle, that is 65.4 degree. Then the third is 180 degree, fourth is 294.6 degree, and fifth is 360 degree. So there were total 5 angles that we have already calculated. Now we will find out what is the maximum fluctuation of energy. So it is nothing but the maximum difference in between these two torques. So by observation we will decide. Now if we observe, here is the point of intersection A and B. So in between A and B, this is very small area. In the same way, in between this point B and C, this is also the small area. But in between C and D, here the maximum area is covered. And here D and E, there is small area. Now how to find out the area covered in between these points C and D and in between these two torques, that is for torque T1 and torque T2. Now here the torques are given in terms of equations. And we will take here now how we will decide. So first by observation, if I decide, suppose I will take integration in between the limits. So now here we have to give limit in between these two angles, for this point C and for this point D. So here for this point C, angle is 180 degree, and for this point D it is 294.6 degree. Now for if I take only equation for torque T2, then the whole area is covered below this, that is up to this line, horizontal line. But here is the torque T1 also, so we have to take only up to this line, or this line for this indicating the equation for torque T1. Then we have to take the integration for T2 minus T1. So what will be our equation to find out the maximum fluctuation? That is, we have to give limits for this 180 degree to 294.6 degree, and in the bracket T2 minus T1 d theta. Now T2, we know what is T2, 5000 plus 600 sin 2 theta, minus again we have to write T1, that is 5000 plus 500 sin theta d theta, and we have to give the limits for angle, that is 180 to 294.6. Now if we solve this 5000 is getting cancelled, so in the brackets 600 sin 2 theta minus 500 sin theta d theta. Now again we will take the integration. So sine of 2 theta d theta means what? It is minus cos of 2 theta by 2. So 600 will remain as it is. So 600 here minus 600 cos of 2 theta by 2. And here sin theta means what? Minus cos theta. So here minus minus will become plus. So plus 500 cos theta. And we have to give 180 to 294.6. That is the limit. So now how to solve this limit? So first we have to put here instead of theta 294.6, and we will take here one bracket. So minus 600 by 2 in the bracket cos of 2 into 294.6 plus 500 cos of 294.6. So one bracket is completed. Now minus sign, because we have to take the difference in between these two limits. So minus sign in the other bracket. Now instead of theta we will put here 180. So again minus 600 by 2 cos of 2 into 180 plus 500 cos of 180. So if we solve all these, we will get the answer, that is 1204 Newton meter. Now we will move for the second question, that is we will calculate what is the total percentage fluctuation of speed. So again we will use basic formula, that is maximum fluctuation of energy is equal to 2 into kinetic energy of flywheel multiplied by coefficient of fluctuation of speed. So this maximum fluctuation of energy we have calculated, that is the answer of first question, and 2 into kinetic energy. So what is the kinetic energy of flywheel? So flywheel is rotating, so kinetic energy is equal to half into mass moment of inertia multiplied by omega square, that is the angular velocity square. So if I put here 2 into half I omega square, and coefficient of fluctuation of speed is Cs. So I is mass moment of inertia, which is equal to m into k square, and omega angular velocity, which is equal to 2 pi n by 60, where n is given 150. So if we solve this for 2 pi n by 60, we will get 15.71. Now we will put all the values. So maximum fluctuation of energy is 1204, which is equal to m mass 500 k square, radius of gyration 0.4 square into 15.71 bracket square into Cs. So what is the value of Cs? That is 0.061. But here the question is that the total percentage fluctuation. So when we multiply here with 100, then we will get here the percentage. So percentage is 6.1%. Now we will move for the third question, that is maximum and minimum angular acceleration of flywheel. So we know that change in torque. So change in torque is T2 minus T1, and when we solve this we will get here 600 sin 2 theta minus 500 sin theta. So how to get this maximum and minimum angular acceleration? So for that we will differentiate this T2 minus T1, that is difference in torque, with respect to theta, and we will equate it to 0, and from that we will get the two angles for theta. So when we differentiate this equation with respect to theta, that is d by d theta, 600 sin 2 theta minus 500 sin theta, which is equal to 0. So what is the differentiation for this sine of 2 theta d theta? That is, it is equal to cos of 2 theta into 2, because 2 theta, that is we have to take multiplied by 2. So 600 into 2 cos of 2 theta. Then again for sin theta it is only cos theta. So again minus 500 cos theta, which is equal to 0. So if we divide here the both sides by 100, then 6 into 2, that is 12 cos 2 theta minus 5 cos 2 theta is equal to 0. So again we will simplify this. So cos of 2 theta we can write here as a 2 cos square theta minus 1. So 2 cos square theta minus 1 outside the bracket 12 minus 5 cos theta. Now if we simplify this, so 12 into 2, that is 24 cos square theta minus 12 minus 5 cos theta is equal to 0. So this is the equation in the form of ax square plus bx plus c. So if we observe here, here the value of a is 24, b is minus 5, c is 12. So what is the equation, or how to get the solution? So here for this cos square theta and cos theta is there. So we have to take value of our answer for cos theta is equal to, we will take the formula minus b plus minus under root of b square minus 4ac divided by 2a. So how to take here, that is minus b. So here a is 24, b is minus 5, c is 12. So I will take here minus b, that is minus into minus 5, that is 5 plus minus under root of 25 plus 4 into 24 into 12 divided by 2 into 24. So when we simplify this we will get 5 plus minus 34.3 by 48. So there are two solutions because of plus and minus. So first solution is 5 plus 34.3 divided by 48, which is equal to 0.8187, and second solution is 5 minus 34.3 divided by 48, which is equal to minus 0.6104. But here left hand side is cos theta. So theta is equal to cos inverse of 0.8187 and cos inverse of minus 0.6104. So when we find it, we will get theta, which is equal to 35 degree, or we will get 127.6 degree. Now when we put the value of angle of theta, which is equal to 35 degree in T2 minus T1, then here T2 minus T1, 600 sin 2 theta minus 500 sin theta. So if theta is equal to 35 degree, then it will give us the maximum torque. So T max is equal to 600 sin 70 minus 500 sin 35, which is equal to 277 Newton meter. Now when we put the second angle, so for that negative value, that is cos theta is equal to negative value and theta is equal to that angle which is equal to 127.6 degree, then it will give us the minimum torque. So for this minimum torque, 600 sin, so 2 theta, that is 2 into 127.6, which is equal to 255.2 degree minus 500 sin 127.6, and which is equal to minus 976 Newton meter. So these are the two values for torque, that is T max and T min. Now for if we use this minimum torque and maximum torque to calculate the angular acceleration alpha. So how to calculate? So for linear motion we have equation force is equal to mass into acceleration. So here for the rotational motion, instead of force we will take here as a torque. So torque is equal to, instead of mass we will take mass moment of inertia I, and for the acceleration we will take alpha. So we have to use the same formula. So instead of torque we will put here T max and T min. So when I put here T max, that is maximum torque, then here also maximum angular acceleration alpha, and when I put here minimum torque, then here also minimum angular acceleration alpha. And we know that how to calculate the mass moment of inertia I is equal to m into k square. So value of m is given, value of radius of gyration is also given in the question. So when I put here T max is equal to I into alpha max, so for this 277 which is equal to 500 into 0.4 square alpha max, so what is the maximum angular acceleration? 3.46 radians per second square. Now in the same way for minimum torque, it is I into alpha min, that is 976, which is equal to 500 into 0.4 square into alpha min. So alpha min, that is the minimum value of angular acceleration alpha, which is equal to 12.2 radians per second square, and this is the answer.